Hello everyone, in this lecture we are going to learn about Leibinitz theorem and problems based on Leibinitz theorem. So now first of all let us define what is the Leibinitz theorem. So if you have two functions u and v, which are functions of x possessing nth order derivatives, then uvn is equal to unv plus nc1 un minus 1 v1 plus nc2 un minus 2 v2 and so on till the nth derivative ncn uvn. Okay. So now instead of writing this way, you can write it as uvn plus nc1 u1 vn minus 1, like this also you can write. Okay. So now let us see a problem where we are going to apply the Leibniz theorem. Now see here, it is a product of two functions. So one is u and another one is v. So which one has to be taken as u and which one has to be taken as v, that we are supposed to decide. So whichever the function which is going to vanish faster, that will be considering it as v in this case. So we are going to use this formula, that is u n v plus nc1. So when you are going to differentiate, that is v1 stands for differentiation and v2 is the second time differentiation of v. So whichever the term is going to converge faster, that is it is going to become it is going to vanish faster, that we are going to take it as v now. So here you have two functions. Let me take u is equal to e power x and v as 2x plus 3 the whole power 3. So after some certain steps v will become 0 when you differentiate. But u, what will happen? The nth derivative of u will remain as exponential e power x itself. For example, what will happen to u1? That is when you differentiate it for first time, it is going to be e power x. When you are going to differentiate for second time also, it is going to be e power x. And if you are going to do till the nth derivative also, it is going to remain as it is. Whereas v, what will happen? When you differentiate it for the first time, this will be 3 times of 2x plus 3 the whole square, and the differentiation of the terms is there inside the bracket will be 2. This is going to give you 6 times of 2x plus 3 the whole square, and v2 will be 12 times, that is 2 will come to the front. So already we have 6, therefore this will be 12 times of 2x plus 3 multiplied by 2. So this will be 24 times of 2x plus 3. Again we are going to differentiate. So v3 will be 24 times of 2. So this is equivalent to 48. So what will happen to v4? So what will happen to this v4? v4 will be, when you differentiate a constant term, this will become 0. And what will happen to v5? And so on. So all the other terms are going to be 0 here. So now we are going to apply the Leibniz rule using this formula. So this will be unv plus nc1 un minus 1 v1 plus nc2 un minus 2 v2, and we are supposed to write till the third term, that is nc3 un minus 3 v3. Okay, all the other terms are 0, so we need not bother. So now this is equivalent to, for u power n it is e power x. What is v? That is 2x plus 3 the whole power 3. Then plus nc1. So this is nc1. Later on you will replace for nc1. Let us retain this as it is. nc1 un minus 1, it is going to be e power x again. v1 is nothing but 6 times of 2x. That is 6 times of 2x plus 3 the whole square. Then plus nc2 nc2 un minus 2 is going to be e power x, and v2 will be 24 times of. So this will be 24 times of 2x plus 3. Then plus nc3 times un minus 3 is e power x, and for v3 it is going to be 48. So in this place it is going to be 48. So now let us substitute for nc1. What is the value of nc1? This is n. nc2 is equal to n into n minus 1 by 2 factorial, and nc3 will be equivalent to n into n minus 1 n minus 2 divided by 3 factorial. So what is the value of 2 factorial? It is 2, and 3 factorial is equal to 1 into 2 into 3. So this will give you 6. Therefore this is nothing but e power x into 2x plus 3 the whole cube. For nc1 it is n. Already you have 6 as a constant. Let us write it as 6n e power x 2x plus 3 the whole square. For nc2 it is n minus 1 divided by 2. 24 times e power x 2x plus 3. And for the next term, it is n into n minus 1, n minus 3 divided by 3 factorial, that is 6, e power x into 48 is there. So here you can cancel out. So this is 8 times, and over here this is going to be 12 times. So the answer will be, so in everywhere e power x is common, so let us take it outside. So the remaining will be 2x plus 3 the whole power 3 plus 6n 2x plus 3 the whole square plus 12 times n minus 1 e power x 2x plus 3, then plus 8 e power x, that is 8 n into n minus 1 n minus 3 into e power x. So this is the answer for this problem. Okay. So now we will move on to the next problem. So if y to the power 1 by m plus y to the power minus 1 by m is equal to 2x, and we are supposed to prove that this is equivalent to 0. So now let us start with the given question, that is y to the power 1 by m plus y to the power minus 1 by m is equal to 2x. This is what they have given. So let us write this as y power 1 by m plus, I can write this as 1 by y to the power plus 1 by m. This is equivalent to 2x. So when I cross multiply, I will get 1 y to the power 1 by m the whole square plus 1 is equal to 2x y to the power 1 by m. So this is nothing but y to the power 1 by m the whole square minus 2x y to the power 1 by m plus 1 equivalent to 0. So by seeing this, you can identify that it is a quadratic equation. It is a quadratic equation in y to the power 1 by m. So you can apply the formula for finding the roots, that is minus b plus or minus square root of b square minus 4ac divided by 2a. So what is the value of a from this equation? A is nothing but 1 and b is nothing but minus 2x and c is nothing but 1. Therefore, this is equivalent to minus into minus will become plus 2x plus or minus square root of, this will be 4x square minus 4 divided by 2a. So this is equivalent to 2x plus or minus, if you take 4 as common and it comes outside the square root, this will be 2 square root of x square minus 1 divided by 2a. So 2 gets cancelled. This a is nothing but 1, right? So let me write it as 2 itself. So when you take 2 common and cancel the term, you will get simply x plus or minus square root of x square minus 1. So we have got the value of y to the power 1 by m as x plus or minus square root of x square minus 1. So let us raise to the power m on both sides. So what will happen? This will become y is equal to x plus or minus square root of x square minus 1 to the power m. Okay, we have got y is equal to, let me write it again, x plus or minus square root of x square minus 1 to the power m. So let us take log on both sides, then only we can differentiate. So this will be log y will be equivalent to, okay, let me write a step here, taking log on both sides. So this will be log y is equal to m log of x plus or minus square root of x square minus 1. So we have got an expression with respect to y and x. So now we are going to differentiate this with respect to x. When you differentiate with respect to x, for log y it is 1 by y, for y it is dy by dx, that is nothing but y1, which is equal to m by x plus or minus square root of x square minus 1, and the differentiation for the term inside the bracket will be 1 plus or minus 1 by 2 times square root of x square minus 1, and for x square minus 1 it is 2x. Okay, so 2 will get cancelled in this term. So this will be m by x plus or minus square root of x square minus 1 times of, when you take the LCM, this is going to be square root of x square minus 1 plus or minus x divided by square root of x square minus 1. So now see here, so So these two terms will get cancelled and the remaining will be m by square root of x square minus 1. And here you have 1 by y into y1. So this can be written as y1 into square root of x square minus 1 is equal to m into y. So you have a square root over here. So we can square the terms. So squaring on both sides, we get y1 square. Here square root will go, so this will be x square minus 1 and this is equivalent to m square into y square. So let us again differentiate this with respect to x, differentiating with respect to x. So here it is a product of two terms. So this will be 2y1 y2 and this is x square minus 1 will remain as a constant. Let us keep this y1 square as constant and the differentiation for x square minus 1 will be 2x. This is equivalent to m square and for y square it is 2y into y1. So this is equivalent to, so in everywhere 2y1 is common. So let us take 2y1 common from these two. So this will be y2 times of x square minus 1 plus y1 into x will be there remaining. And here also it is 2y1 m square. So what will happen if you divide this by 2 into y1, you will get y2 times of x square minus 1 plus y1 into x is equal to 2y1 will get cancelled and remaining will be m square into y. So I can rewrite this as x square minus 1 into y2 plus x into y1 let me bring this m square over here. So this will be minus m square into y is equivalent to 0. Now we are going to differentiate the same for nth time. Okay. Differentiating n times with the help of this Leibinitz theorem, that is UVN is equivalent to UNV plus NC1 UN minus 1 V1 plus NC2 UN minus 2 V2 and so on. Okay. So we are going to differentiate n times with respect to Leibniz theorem. Only in these two terms we can apply. Here it is a product of two terms. Here also it is a product of two terms. So here it is only one single term. So there we need not apply. So only in these two places we are going to apply the Leibniz theorem. So this is equivalent to, so let me write the step again, the same step again. That is x square minus 1 into y2 is there. Then plus x into y1 minus m square into y is equal to 0 is there. So now let us apply, for this term we will apply the Leibniz rule, the theorem, and for this term also we will apply. So what will happen, this will become x square minus 1. We are going to differentiate it for the next level, that is n plus 2, then plus, when you differentiate this term, x square minus 1 will become 2x. So nc1 into 2x and 1 less than that. So this will become yn plus 1 plus nc2. When you differentiate this 2x, this will be 2 times yn. Okay. So when you differentiate the first term, it is going to give you 3 terms. And what will happen to the next term? Constant will become 0. So we need not bother. Now let us consider the second term. You have x into y1. So the differentiation will be x into yn plus 1 plus nc1. Differentiation of x is nothing but 1 into yn. So yn plus 1 will become yn. Then minus m square into differentiation of y is nothing but yn, which is equivalent to 0. So this is x square minus 1 yn plus 2 plus 2nx. nc1 is nothing but n, therefore this 2nx yn plus 1 plus 2 times of n minus 1 divided by 2 factorial is 2 into yn plus x into yn plus 1 plus n into yn minus m square into yn equivalent to 0. So these two will get cancelled. Now let us try to collect the terms. So first term will be the same because there is only yn plus 2, only one term, and when you collect this n plus 1, so this is equivalent to, so this will give you 2n plus 1 into x yn plus 1. Then the remaining terms are all yn terms. So this will be plus times of n square minus n, then plus n minus m square into yn equivalent to 0. So this plus n and minus n will get cancelled, and the remaining will be x square minus 1 into yn plus 2, then plus 2n plus 1 x into yn plus 1, then plus n square minus m square into yn equivalent to 0. So this will be the required differential equation. Thank you. We will stop with this.